Thank you.
So good afternoon. I want to start with a few words of thanks. I want to thank first and foremost the members of the panel. We appreciate the time and expertise that you're bringing to these really critical issues. We are grateful to get your scientific input and appreciate the forthcoming report. I want to thank the academies for facilitating the meeting today and the panel as a whole. And then I also want to thank my fellow sponsors or the fellow sponsoring agencies for twofold reasons. One, for your shared interest in this public health issue, and then also, since I didn't have the foresight of some of the prior speakers to tag team the presentation, I do at least have the good fortune of having been picked third in the order of presentation, so I don't really have the obligation, I don't feel the obligation to go into the technical details since they've sort of plumbed the depths of many of the specifics of the technical issues that I'll have to talk about today. So, with that, I'll go ahead and start my presentation. I want to start first by explaining the agency's interest and why we've decided to sponsor this activity. Give you a little bit of history on the regulatory background when it comes to Legionella and the purview that we're looking at this in, and then talk about some of the technical assistance that we have tried to provide to the stakeholders that we work with, and then identify what we see as the challenges. The technical challenges and the scientific challenges we see going forward. So we'll go to the next slide, or am I in charge here? Oh, there we go, thank you. Okay, so first and foremost, the agency, EPA's interest within the National Academy study here. I want to say that I'm speaking to you as a representative of the agency, primarily focused in our capacity in overseeing the implementation of the Safe Drinking Water Act. So let me just make sure that everybody has a firm understanding of what the Safe Drinking Water Act is. It is a law passed over 40 years ago. It is the authority by which agency has to regulate public water supply systems. So there's systems that supply drinking water to 25 or more people, or have at least 15 service connections. And so these are the large public water supply systems. It is not an authority for us to regulate private buildings, nor is it an authority for us to regulate private wells. So we are primarily interested in that, but we obviously have significant concerns about legionellosis from our overall mission to protect public health. So I'll be primarily speaking from the perspective of the authority we have within the context of the Safe Drinking Water Act over public water supply systems. So we're worried about Legionella. We continue to remain concerned about Legionella because of the major health concern and its inherent association with drinking water. We want to better understand the science and other information related to the focus areas of this study. We expect to utilize the outcome of this study and other research that is forthcoming to improve the technical assistance that we're providing to the states that we work with to implement the Safe Drinking Water Act, the local governments, the public water supply systems, and the key stakeholders to help them better manage the risks associated with Legionella in drinking water. So let's move now into how we currently regulate Legionella in the context of the Safe Drinking Water Act. The primary regulation that's in play here is the Surface Water Treatment Rule, which is a regulation that dates back to 1989. So this is a regulation that applies to all public water supply systems that use a source water that is either surface water or what we refer to as groundwater under the direct influence of surface water. When we establish drinking water regulations, we must first start with a public health goal, referred to as a maximum contaminant level goal. It's a level at which there's no adverse risk to the health of humans with an adequate margin of safety. It is not the enforceable level. It is, as its name would imply, the goal for the regulation. So we established that a goal, an MCLG of 0 for pathogens, including Giardia viruses, and we also established an MCLG of 0 for Legionella. To achieve the enforceable action under the regulation, we established what's referred to as a treatment technique. We determined that it was not economically or technologically feasible to measure all the potential pathogens that water systems would have to remove. Therefore, we established the treatments that water systems must institute to remove those those pathogens. And so in the case of the surface water treatment rule, we focused, when we established the treatment technique, primarily on Giardia and viruses. And I think there was an inherent belief at the time that we would also be removing Legionella with the disinfection and the filtration that we would require. But that is a primary disinfection and filtration practice that is put in place at the water treatment plant. And then there is an additional requirement within on the systems, particularly the surface water systems, to maintain a detectable chlorine residual or detectable disinfectant residual throughout the distribution system. Although water systems do have the option, if they want to demonstrate that they don't need to maintain a disinfectant residual, that they can do monitoring for heterotrophic plate counts to demonstrate that they don't need disinfectant. So that is the primary regulatory mechanism that is in place to assure safe drinking water when it comes to Legionella. There's a couple of other regulations that are quite relevant to Legionella. However, the first would be the total coliform rule, or as we refer to it now, the revised total coliform rule. So what this regulation requires is of all public water supply systems, and this is irrespective of their source type, so this applies to both groundwater and surface water systems. It requires monitoring at locations throughout the distribution system for total coliform and E. coli. And those are used as an indicator of potential treatment upset or contamination of the entry points or of biofilm growth within the distribution system. The revised total coliform established that systems that detect high levels of total coliform E. coli must undertake what we refer to as a find and fix. They must, depending on the number and frequency of those detections, either independently or in concert with the state, undertake an investigation to try and determine the source of the contamination, and then take actions to remedy the contamination to prevent future occurrence from total coliform. In the case of groundwater systems, there's another regulation that a total coliform positive will trigger a source water sample under the groundwater rule, and I'll talk about that regulation next. Okay, so the groundwater rule requires source water monitoring either through this triggered monitoring requirement or a state-directed assessment monitoring to test for the presence of one of three fecal indicators, E. coli, enterococci, or coliphage. If the sample tests positive, then remedial action is required by the system, including disinfection, but other actions to remedy disinfection, or I'm sorry, to remedy the contamination are also possible if they're approved by the state. The other aspect of the groundwater rule is that it requires a sanitary survey, a comprehensive evaluation of the system, including the source water, the treatment, the distribution system, pumps, and finished water storage to identify any significant deficiencies. I should note that this sanitary survey requirement also applies, it's not exclusively to the groundwater systems, it also applies to the surface water systems through yet another regulation called the Interim Enhanced Surface Water Treatment Rule. And so then water systems, if a state in conducting a sanitary survey identifies a significant deficiency, then there's an enforceable requirement for that water system to actually remedy that significant deficiency within the timeframe specified. So those are the existing current requirements right now in public water supply systems that are relevant to the presence of Legionella. However, the agency just recently, a little more than a year ago, completed a comprehensive review of our national primary drinking water regulations. So the statute actually requires that we conduct on a 6-year basis a comprehensive review and identify whether or not there's opportunities, or whether or not a revision to the regulation is appropriate. And then it also further specifies that any regulatory revision must maintain or improve public health protection. So actually, it was our third cycle since the 1996 amendments that we just completed in January of 2017. This was the first round of our comprehensive 6-year reviews in which we actually looked at the microbial and disinfection byproduct regulations. We had largely not looked at those because there were active revisions to those regulations going on in the prior reviews. So this is the first time that we did a comprehensive assessment of those regulations. Our findings back in, again, a little over a year ago were that there were 8 drinking water regulations that we identified as candidates for regulatory revisions. Now, those regulations are the Stage 1 and the Stage 2 disinfection byproduct rules. They also are the surface water treatment rule that I mentioned, the interim enhanced surface water treatment rule, and the first long-term enhanced surface water treatment rule. So we've identified these regulations as areas for potential revision. And if we can get a little bit more, and specifically with regards to the surface water treatment rule as it applies to Legionella, we've identified that regulation as a candidate revision, and we are considering a number of pathogens within the context of this regulation. Legionella certainly being one of them, and for which an MCLG has already been established, but other opportunistic pathogens such as Mycobacterium avium, as well as Pseudomonas. And so this remains these organisms remain of keen interest to us because of the potential to improve public health through improved drinking water regulations or other actions that the agency might take. The key elements that we identified in going through our review of the existing regulations for the surface water treatment rule had to do with that disinfectant residual requirement that I mentioned of the surface water treatment rule. One of the things that we are currently evaluating and studying is the numerical values, the disinfectant residual levels that might be appropriate for consideration. As I think I've mentioned already, right now there's a requirement for simply a detectable residual in distribution systems. And so we're evaluating whether or not it might be appropriate or whether or not be advisable to consider numerical values. Also distribution system management measures, other measures that could be considered within the context of either regulatory revisions and or other guidance that we could give to public water supply systems on ways to manage distribution systems to reduce intrusion, leakage, to deal with main breaks, cross connections, and pathogen growth in storage tanks remain among the topics that we continue to try and gather more information on as we consider whether or not to proceed with any further revisions to the surface water treatment rule. So shifting now from our role as the regulatory agency when it comes to public water supply systems to our role as the technical, in trying to provide technical assistance to the stakeholder community. One of the things that we did recently, largely in response to requests from our state partners who were increasingly facing inquiries and requests on how to address building managers who were interested in water treatment systems. We worked with our colleagues in the States and also received input from our colleagues at the Centers for Disease Control to prepare a compendium of what the literature says about the efficacy of technologies for controlling Legionella within premise plumbing systems. So we put this compendium out back in 2016. We believe it provides a robust characterization of the effectiveness of the treatment technologies that are out there for control of Legionella, and based on the findings of peer-reviewed literature. Again, as I said, we developed this largely as a tool for our state and local officials and tribal officials for them to use as they're evaluating and trying to respond to risks associated with Legionella in premise plumbing systems. Not directly related to Legionella control, but somewhat relevant. We have another office within the Office of Water who administers a program called WaterSense. It's an EPA-sponsored voluntary partnership that seeks to try to conserve drinking water, and it publishes standards and identifies products that are associated with water conservation. Recognizing the connection between water conserving fixtures and potential exacerbation of Legionella and other risks. One of the most recent best management practices for commercial and institutional facilities has some sections talking about types of plumbing fixtures, particularly for healthcare facilities, that can be used to lower their risk of bacterial contamination. So this is where I get to the point of the presentation where I'm really relying on those who went before me. So I think it's been, as I said, it's been detailed quite extensively by some of the previous speakers. And so our characterization of the needs going forward really are more at a much higher level. We see significant needs both at the federal level, state and local level for for public water supply system operators and facility managers. They need better tools right now to assess Legionella risks. I think there's been a lot of discussion so far about indicators and the various assays and their efficacy and what those results tell us. We think that we would really value and appreciate input from this group about what are the most important risk factors that are the best indicator of Legionella risks. Many of the topics have already been discussed: nutrient availability, biofilm conditions, water age, the relationship with amoeba, corrosivity of the water, or the presence of the absence or low disinfectant residuals. All of those are potential factors. However, we definitely think that there's an opportunity to identify the most critical of the risk factors. And then when it comes to managing Legionella risks, we are anxious to hear your expert input on what you would identify as the most effective management strategies. How can the different management strategies complement one another, particularly in situations where maybe Legionella monitoring results have indicated the presence of Legionella. We're particularly interested in your thoughts on what the most appropriate management and mitigation strategies are in those situations. Last but not least, we need, and our colleagues and stakeholders need, risk communication tools. What's the most effective way to communicate the risks to the public associated with Legionella, both the general population, then of course to the at-risk population? How can we best instill consumer confidence and public health protection at the same time? And then obviously, how can building owners and public water supply systems effectively communicate these risks, as they're often called to do? So that's for the most part the end of our presentation. A few resources we have here on the slides. Some of the issues that I've mentioned already, the results of our 6-year review that I talked about are on the 6-year review webpage, the technologies document for Legionella control and premise plumbing, and then the WaterSense document. I will say, in addition to the material that I've covered in terms of regulatory perspective, I should identify and acknowledge that our colleagues in the Office of Research and Development have significant work underway. We've got a fairly comprehensive list from them of some of the projects that they have underway. I'll be happy to share that list with the committee members so that they're aware of that ongoing work and have the contact information for those folks. So I think I've made up a substantial amount of time in your schedule today. Well, I'd be more than happy to go to the next section as well, too.
Try to remember to introduce yourself for our online.
This man needs no introduction.
Mark LeChevalier. Eric, the Legionella had been on the CCL, the contaminant candidate list for the last for 3 and 4, for the last 2 lists, and so by putting in that list, EPA then looks at the opportunities that we could gather additional information on that contaminant by evaluating methodologies and opportunities for monitoring. And if that opportunity presented itself, then the administrator has the ability through the UCMR to require monitoring for that contaminant. What has been the limitation EPA in moving Legionella to a UCMR monitoring, and what has the agency done, and where are the roadblocks in that process?
So thanks for your question. Yeah. Yes. More slides next time. So thank you, Mark. I'm going to give a little more background for the folks who don't fully understand the context in which you're posing that very good question. Legionella is, under the Safe Drinking Water Act 96 amendments, there's a risk management paradigm in which the agency first identifies contaminants that may be in drinking water and may require regulation. Mark's pointed out that the agency has identified Legionella on that list, actually, I think, going back to the first CCL. One of the next steps in the process is for the agency to make a regulatory determination for at least 5 of those contaminants. And one of the things the agency has to do is determine whether or not Legionella occurs or may occur with substantial likelihood or with frequency and at levels of public health concern in public water supply systems. And the Congress authorized us to, with an authority called the Unregulated Contaminant Monitoring Rule, where every 5 years we can put out a list of up to 30 unregulated contaminants for monitoring. And so Mark's rather pointedly asking me why the agency has not yet included Legionella on that list. And I'll point out, and he's also pointing out that we just last month began the UCMR4, the 4th cycle of the Unregulated Contaminant Monitoring Rule. So I think, Mark, the answer to your question is why have we not? I think some of the issues that we have faced is the degree to which we've got a method that we think is reproducible and valid. And I'll point out that when we require water systems to monitor the UCMR, we're requiring upwards of about 5,000 water systems across the country to do that monitoring. And so we need to make sure that there's adequate laboratory capacity. They're going to have consistent results amongst those laboratories. And so one of the concerns has been the availability of a method that we could have confidence in with respect to that. I think that some of the other concerns, because we are capped in terms of the number of contaminants that we can monitor for, some of the competing interests in terms of some of the other emerging contaminants of interest comes into play there. So I think those are the primary reasons why the agency has contemplated that. I will also point out that the degree to which we can say that the monitoring results might represent a level of health concern is not a direct factor when it comes to selecting contaminants for the UCMR, but that would be a challenge if we were to require water systems to do that.
So you've looked at and evaluated there wasn't availability of methods, or there wasn't the commercial capability of doing a method?
I think it's a combination of both of those, Mark. I think to some degree, we looked at we're not saying that there aren't any methods out there. The previous speakers have been talking extensively about some of the methods that are out there. I think what we've evaluated is the availability in the drinking water realm. I think the other issues that come into play when it comes to monitoring for Legionella in drinking water systems is what's an appropriate sampling protocol. This is an organism that we worry about in the context of the biofilms of the distribution system. If we're simply to take tap samples or samples from the free-flowing drinking water, there's also concerns about whether or not we've got representative samples in that context. I think I have a helper from my, do I get to phone a friend in this scenario? No, he's not asking me a question. He's helping to answer. He's correcting the mistakes.
No, everything that Eric said was fine.
However,
the other issue we struggle with was how we would interpret the occurrence in terms of risk. We have a huge range of dose-response implications, and what the measurement would tell us in terms of risk communication would have been very challenging. So that was a big piece.
Thank you, Stig.
Okay, I'm not going to ask you any easier one either. Chuck House from Drexel.
Yeah, okay.
So I really want to start a high-level picture, and it bothered me 10 years ago when we did the distribution system study for the academies. I think you basically said that EPA does not have authority to look at what happens within buildings. And I'm old enough to remember the passage of SDWA, and it was always sold on source to tap. And so there seems always to have been a disconnect between the original intent of SWDA and the way that it's being interpreted now. And so help me through my misunderstanding.
Well,
He's retired, he said.
So good to see you too, Chuck, and thank you for your comments. Chuck, you're right. I mean, the concept of source to tap is certainly a large part of the promotional and information that we try to make sure that we have. So the legal definition of a public water supply system is really what I'm referring to when we talk about this. And so what the Act gives us is the authority to regulate public water supply systems, and the language specifically goes into a lot of definitions as to what constitutes a public water supply system, including and I think the operative phrase here is, and the portions of the distribution system in its control. And so then, there's been a lot of debate about what constitutes control, and mostly in the context of some other regulatory requirements, but largely the agency has defined control as ownership. So, and this was mostly done in the context of lead and copper rule. So what the agency has defined is that the regulated entity stops where that public water supply system owns it. So in most cases, it's at the property line of said building.
Yes, so it's Lanching Weeks from Canada. I just wanted to know if there are requirements in the U.S., either formally in terms of laws or internally for different organizations, to report to public health agency if concentration of Legionella exceed a certain limit, because in Canada we do.
Yeah. So there are no monitoring requirements for public water supply systems to monitor for Legionella. Therefore, there is no reporting requirements associated with a particular threshold. The monitoring requirements, as I summarized earlier, focus on total coliform and then the treatment techniques associated with disinfection and filtration.
Tim Keener, a question kind of following up on what Chuck said. You had mentioned that you're looking at how we can control Legionella in drinking water systems, and to me, probably the #1 problem out there that I see is the Safe Drinking Water Act. There's a sentence in the Safe Drinking Water Act that says if you add a biocide, you're a public water system. So if I'm a hospital and I add a biocide to treat my hot water, I become a public water system. Most states use common sense and don't implement that unintended wording. But if I'm in Ohio or Pennsylvania where I have zealots in charge, they don't use common sense. I've got 3 outbreak customers in Ohio that stopped treating their water for Legionella because every time they did, they got fined for being not in compliance with the Safe Drinking Water Act. They had more THMs coming into their building than they could do. And I had one customer that was treating their water that ended up spending $750,000 because they failed their lead test. Their first lead test was 0 lead in the building. Their second lead test was 100 times higher at every outlet. And the EPA said, you've got a lead corrosion problem. They didn't have the smarts to look out and see there was 8 miles of street being dug up and pipe replaced. So I met with EPA March 3rd, 2003, 15 years ago, went through a presentation, said the impact of these unintended words, what will you do? I'm asking again, what will you do?
So I think so if I understand your question, you're asking me about the provisions of the Safe Drinking Water Act that declare a water system to be a facility that adds treatment, or I believe the other operative phrase is that if it bills or adds treatment, it becomes a public water supply system. You're asking, that's the concern that you have, and the degree that that imposes a requirement that any system that starts treating becomes a public water supply system. So I will point out that that is a provision of the law. It is not a regulatory requirement that the agency has promulgated under the law. And so the issue that I think you've identified is a legislative one that I'm not really in a position to modify or change. This is legislation that Congress will have to take up.
But the Safe Drinking Water Act is the legislation you're talking about, right?
Yes.
So you would have to change it and submit it to Congress to get it to be changed.
No, that's not the way the process works. Congress passes the Safe Drinking Water Act and gives us authority to promulgate regulations within its scope. We do not tell Congress. We don't tell Congress anything. We follow the legislative mandate that Congress has established. I should say, the president, of course, has the authority to develop legislative mandates. He hasn't asked me for any.
I think one of the things we'll grapple with in policies is this integration, across jurisdictions. That's definitely an issue with Legionella. We have another question here.
Hi, I'm Catherine Alfredo from DC Water. So one of the things that it's come up a little bit in different questions, but if Legionella and other pathogens are actually going to start to be looked at from the Safe Water Act or through the Surface Water Treatment Rule, then almost all of our discussions have been on premise plumbing, and then sitting there as a distribution system and a treatment facility, then how are we then addressing that? Because it seems like everything has been talked about, amplification in the premise plumbing and in homes, but it's coming from somewhere, and we don't really, action levels was something that was brought up in the VA one, and we've been thinking about our own response plans, but there's not enough out there to develop actionable levels or to understand when to go to the public. And I think this is something that needs to be considered as something like Legionella is brought up as UCMR4 or in the next UCMR or as part of the CCL, is that, well, if we detect it, what are we telling our customers? Because we already have a loss of faith in a lot of places with our utilities because we're detecting more and more things, we're testing for more and more things. So if we test for this, I just feel like we need to have a plan also on what we're going to tell people.
So I think I'm in agreement with your comment, and to some degree I think you've said the things that were on my slide right there. So I think just to be clear, we've identified the Surface Water Treatment Rule as a candidate for revision, and we're also looking at and trying to identify other technical assistance we can provide to the stakeholders that we work with. But we acknowledge that there are significant uncertainties and data gaps, and so that's one of the things we're trying to further assess and evaluate before we move forward with any policies. So
we've got an online question, and then I think we have one more question up here, two more. Yeah, two more, and then we'll move on. So the online question, please.
I don't have a full name or affiliation for this question, but Marcy asks, there are studies that show Legionella bacteria thrive with high levels of total organic carbon and assimilable organic carbon. Does the EPA recommend TOC/AOC removal for all water treatment plants?
So it's a great question. I think one of the things we recognize is the nutrient availability is one of the potential indicators of Legionella. And in the context of pathogen control, I think the answer to that question is no. However, in the context of our disinfection byproduct regulations, where we mandate some precursor removal, enhanced coagulation, that can be a mechanism by which some of those precursors can be removed.
Nick Ashbolt, University of Alberta. In light of the previous questions as to why we're not monitoring at the moment, you mentioned the lack of agreed to methods perhaps being one of the key issues. But what about the maximum contaminant goal of 0? Because if you do detect with that goal in place, you have to then report, as I understand it, as an agency distributing water. So is that not another disincentive? Is there a rationale perhaps to modify that 0 goal? Because on the one hand, a 0 is in a sense a nonsense, unless you want to measure all the water. And on the other, it may be an impediment for people investigating their systems.
So that's a great question, Nick. I think that one of the premises you've made there, I'm not sure is right, and it'd be one I'd have to spend some time with the lawyers to try and figure out. So, but it's an interesting, Legionella is a unique contaminant in that it exists both in the regulated realm and the unregulated realm on our CCL. We've put it on our CCL in part because we recognize that there's more information that needs to be gathered about whether or not the regulations that we've applied to it are effective and whether or not there's an opportunity to improve those. So what you're positing is that if we were to require monitoring for Legionella by virtue of having an MCLG of 0, there'd be some sort of additional notification required associated with it. And I'm not sure how that.
Yeah, but it may not be a legal requirement, but for example, a certain Midwest utility basically spelled out that would be the outcome if we were to start looking for that organism. And so they tend to be using it as an excuse, perhaps even it may not be a clear legal requirement.
Yeah, so, right, so I think that is a good point, because under the unregulated contaminant monitoring rule, all systems are required to report those results, and the degree to which they find anything, we also advise that they share those results with their consumers. We don't mandate, but we suggest that when they provide those results, they provide any related health information. We primarily identify our health advisories, although I think you're saying here that folks would say the MCLG would be the relevant standard. So that's an interesting paradox. It's certainly not that hasn't entered in our minds when we've contemplated the UCMR monitoring, but it is an interesting question. I don't know.
Having spent a little time in this business, a few comments, and I'd like to defend Eric in several of these questions. Number one, there is no legal requirement that people notify on an MCLG. Some states may require it. Some communities may do it because they like to self-incriminate, but it's not required. And the MCLG, by the way, is not 0 the number, it's 0 the word. And it's described, and that's deliberately done because it's described as an aspirational goal, not a numerical target, but an aspirational goal. In other words, we work in that direction, but we really don't think we're going to get there in most of the time. And that's been in court. Secondly, on Mark's question, I got a whole list. On Mark's question, well, I'm helping Eric. On Mark's question about the UCMR.
I guess I am a tag team speaker. I didn't realize that.
Mark's question on the UCMR. From my perception, it's just not appropriate to do Legionella by UCMR because UCMRs are typically survey type studies where you take a sample, you analyze, and you tally the data. Legionella requires site-specific research design. You know, it just doesn't make a lot of sense to take a lot of samples and then see what happens. It has to be very, very focused. Same thing goes for microcystin, by the way. Taking a survey of microcystin doesn't really make any sense. You should do it if you have an algae bloom. You know, that's when you look, but you don't do it randomly. Okay. Thirdly, on the matter of regulation at the tap, and I think EPA has a real legislative barrier there. It's a problem because there are indications in the Safe Drinking Water Act that its authorities really pretty much end at the meter, although it does talk about to the tap. However, they were challenged on that in the lead and copper rule back when. And the appellate court did not utter a ruling, but they made it pretty clear that EPA was probably sledding on very thin ice when it was applying requirements past the meter relative to lead and copper regulation. So I hope you appreciate my help. The idea is that Legionella is a big deal. It's really serious. And so it does warrant a lot of activity. And I think EPA has a lot of tools that it can apply. They are short of regulation, but they are essentially the same consequence as a regulation. And if you remember, when we invented health advisories about 30 or 40 years ago, there was nothing in the law about that. We did it because there was a need. People were asking for it. And now health advisories are virtual regulations. People in the field out there take them as regulation. They should not, but they do. So I'm saying there is an authority that EPA has that it can provide advice and recommendations, and they are very, very likely to be taken by the states, literally.
Thank you.